Thank you for the opportunity speaking here. I'm very exciting. And this is the first Jupyter conference. I didn't realize that this is such kind of huge conference. So anyway, I'm project researcher, National Institute for Informatics. That's a kind of research institute. And I'm developing and managing a private cloud in the institute and helping researchers and students for cloud operation or middleware or something like that. So I'm always struggling with such kind of support work. That's a very variety of things. Yeah, we do have some open stacks, and we set up software stacks and consulting the configuration. And sometimes we do some optimization and troubleshooting. So we apply Jupyter Notebook to operate these engineering operational works for years, maybe 3 years now. And on the course, we did some extension to the Jupyter Notebook. Those things are on the GitLab. So please verify if you will be interested. So today, I would like to talk about my problems, domains, and motivation, why we started to use Jupyter Notebook. And then next, I will briefly introduce our extension to the Jupyter Notebooks for infrastructure operations. Then at last, I will introduce what we have learned and where we want to go. So we call our project as Literate Computing, Reproducible Infrastructure. And when we started this project, there was not Jupyter yet, just IPython. At that moment, we'd like to automate our operations, infrastructure operations, and share such kind of operation knowledge with technical and non-technical, sometimes a researcher or a student. So for that purpose, we seek some tools how we organize these kinds of knowledge. So our goal is something like automated operations. So IT operation needs some traceability or reproducibility. So we decided to use a Jupyter notebook, IPython notebook at that moment. So later on, there is a Jupyter, so we have been switched. Also, another goal is a collaboration. So we'd like to share how our infrastructure should be built. Not just like automations. We'd like to share the knowledge behind how to design and manage infrastructures. That's the kind of our goals. So that is a very practical problems we have. So we do manage our infrastructure like an OpenStack cloud or something like that. So daily operations should be should have more qualities and robustness. So we need some traceability. Also, we'd like to reuse some procedural knowledge. So, and also we'd like to share such kind of knowledge with technical people and non-technical people and students. So in that age, there was DevOps cultures. There is an approach for infrastructure as code, but then that's something different from our goals. So traditional DevOps tools is something like automation within a silo. For the deployment, there is automation tools. So maintenance, there is some operational tools or supporting tools. But each silo is divided. So we'd like to collaboration beyond these silos. So we seek some tools appropriate. There was a wiki or a conference or some trouble IDS tools, but that's not enough. And then find IPython notebook. That's something narrative tools, which may fill the gap between the documentation and such kind of existing automation tools. That was our first feeling. So what we are doing is just operation make reproducible. That's straightforward. We can use a notebook for that purpose. But then it's just replace the terminal to the notebook. So, so I'm not familiar how you are. I'm not sure how you are familiar with operation things. Okay. So in usual, we have some management server. So IT operator log into the server and do some job or command through the server, through the SSH or terminals. But for that purpose, we put the Jupyter notebook server and then all operations through the notebooks. That was what we are doing. So for that purpose, notebook is very useful, but it's only shared knowledge. Sorry. So, but we'd like to make prerequisite reproducible too. So in usual some procedural document, there are some procedures how to install, how to build, how to set the parameters. But in each document, there is some prerequisite. You have to meet these conditions before to operate, use these automated tools. But we'd like to make those prerequisites reproducible too. So that means we want to share whole experience, how to build or how to manage infrastructures. So we use narrate. So in that sense, narrative stories, a narrative feature is very useful. And that is something different automations. I'd like to distinguish automation and automated operations. Automation is something like a DevOps people's, just one click or just one line command, doing everything like immutable infrastructure or virtual machines or something like that. But then automated operation involves in a human. So we have a feeling. So infrastructure is not always immutable. It's a kind of system. So one day you create some HDFS Hadoop cluster on some area on specific conditions. Maybe 2 months or 6 months later, OS may change, and some condition may change. Sometimes the network structure will change. So we'd like IT engineer have to follow these changes. So we need something, what we call that the binding. So we need to manage or expose how we bind some knowledge or procedural things to the real world. So it's just beyond automation. And it's a kind of pretty similar to documentations. But then through the Jupyter notebooks, such kind of documentation has concrete binding to the real infrastructure or real world. So in that sense, we use the word literate computing. Just simple computational things. So we have a flavor of art or documentation skills, on top of that. And this is kind of our big picture. So we don't, we also, we just use a notebook. We also use a traditional IT tools like Ansible or some package managers. So on top of that, we wrap all operations or all procedure with notebook. So we describe operations through notebook, and we will refactor these things and then share knowledge as expert and apprentices. Also, when so we prepare some infrastructure for researchers. So we deploy some cloud cluster and bind some notebooks. So if we prepare a Hadoop cluster, we will bind management notebook for Hadoops to the cluster and then provide to the user or researcher. And researchers continue to operate those notebooks, those clusters through the notebooks, so they can share refactored knowledge from us, technical people. So this is a kind of big picture we'd like to achieve. So let's go into some details. When we describe the operational procedure in a notebook, this is a typical daily operations. Acquire some logs from the servers and then analyze such kind of logs and then troubleshoot or make a performance report or something like that. That's pretty similar for data scientists are doing. This is no difference. But then for the daily operations, we use notebook as on the management server for daily operation, capturing daily operations. So in that sense, our operator when our operator does something, they create a notebook, new notebook on a dated and then what they are going to do. And all operations through the notebooks. So we have evidence what have done, and then that we can assure the traceability for each operations. We keep errors or failures. we don't we forbid the operator not to erase some unusual things or failure things. We force operator to remain everything. So that's the kind of things. So for that purpose, and then notebook has we like to control the notebook extension for that purpose. So we do some extension, develop some extension. I will explain later. And as reusable notebooks, in the case of Hadoop clusters, notebooks consist from 25 procedures consist from 25 notebooks and 55 playbooks. This is very complicated, but then we elaborate these things from several experiences. So first time we do Hadoop cluster for teacher A, and next day for project B or something like that. Every project or every instantiation have different aspect. So based on the accumulation of our experiences, we refactor these notebooks to these categories. And so at that result, that grows to this way. But maybe how you can, these are some notebooks. So maybe you can see some D or O on heading. D means notebooks called deployment. O means for notebooks for after deployment maintenance things. Like in the case of Hadoop, decommission some nodes or recovery some error nodes or something like that. So actually, procedures for deployment and operation things have some relationship. So those things have to be maintained consistent. So these represent operators, engineers' knowledge as a result. And this is our deployment scheme for Jupyter. So we do manage our private cloud. So there is a central management server, and there is Jupyter. So daily operations, which I show you, is performed on this Jupyter. And when we provide the cluster for this user, we create the cluster and the notebooks, how to create, how these clusters are deployed. Every evidence and configuration is on notebooks. So user can verify what has been done, and then whether these deployment meets, they can verify deployment details by themselves. And also, we do things on the public cloud as well. In that case, we have Jupyter Hub for serving notebooks. Through these notebooks, user can deploy cloud or middleware or something like that onto the public cloud. Actually, on the GitHub, we have an example for deploying Elasticsearch cluster. That notebook present how we do these things. So, and we think through the notebook, we can share reproducible experience. So experience means if something moved, target has been changed or environment has been changed, experienced people can reproducible similar things. So that transfer skills and knowledge, we need experiences. So just notebook which describes the procedure, but we describe the bindings with the notebooks, and in that binded notebooks, there are outputs how actually binded. So these things can be shared. So so in that sense, when there is a pattern notebooks on the GitHub, these contain the output as well. So if you apply these notebooks to your environment, you can verify what's difference from the output as well. So in that sense, we like to say we can share experiences. So next I will explain some our enhancement to the notebook. So infrastructure operations, we like to secure output and also prevent misoperations. And because such kind of notebooks has a very complex bunch of collections, we'd like to some perspectives those set of notebooks. For that purpose, we do some they made some extensions. So there is wrapper kernel. So wrapper kernel is for securing output. So when in the case of infrastructure operations, output line may be exceed 100 lines or 1,000 lines. In that case, web browser will be stuck. So we make a wrapper kernel which summarizes and first specified lines and tail specified lines, also displays errors. And in the background, those whole logs are stored into the individual files. That is one thing we developed. And this is enhancement of collapsible headings. This is a whole procedure that's very long and complicated. And just this portion will looks like this. And collapse headings shrink these portions just 3 or 5 lines. But in that case, execution cell is hidden under the collapse heading. So we put bricks for the hidden execution cells. So that will show how things are going for operational perspectives. Also, you can go through this set of bricks, just one click. And if goes successful, that will turn to green, and if there is a failure, red. And in the case of red, you can expand the headings and then examine what happened. That is another extension. So some typical use cases, and we can create some notebooks for validation or diagnostics. So sorry, these notebooks are Japanese, but then we can create a diagnostic procedure and then collapse those in this way. And just one click, all validation will go through. And if there is no error, it's turned to green. So that is very handy to create such a verification task or something like that. There is another activity. As I show you, notebooks have infrastructure operation notebooks have a bunch of collections of notebooks. So we like to some visual relationships. So in this case, we use a block diag, that's web services or Ajax things. And actually, these stuffs are on the GitHub as well. Block diag creates these diagrams from the declarative list of things, but it just boxes. But these are SVG, so we inject notebooks headings into the box and links to the box. So we turn the block diag to the interactive map. That's another thing we are doing. So we code. So our activity is something like create some dynamic documentation for the infrastructure. So sometimes we need these kind of diagrams. What idea is in a set of notebooks, and for the first time we create this diagram by manual. but it's difficult to maintain. So in the second stage, we try to use block diagram to create these diagrams, so declarative ways. And at this moment, we inject additional information to the notebook, so we can create some interactive maps. So these are typical work we have done. So already 30 minutes. Actually, Jerry, we packaged these kind of extensions into the Docker image. You can pull image, and you can examine by yourself. So in this way, so this is sample notebook. And this is a kind of bilingual notebook. You can switch to Japanese or English. This is an extension of one of our extensions. For the run-through, so this here, trust notebook. So under these headings, there are four cells. So you can execute cells, and this is error. And you can fix and continue execution, or back to the bricks and continue. So there is a snowflake. This means that this cell is frozen. You cannot change, or you cannot execute again by accident. But these kind of things assure the robustness of operation as well. This is a wrapper kernel example. You can set parameters for how many headings or how many errors. So, okay. So in this way. So after execution, there is a path to the log file. You can examine the whole log as a file. So there is a starting time and at the bottom end time as well. Also, this one includes a script which are actually executed. All things are logged through this node. Sometimes command takes 1 hour or 2 hours. In the middle of execution, web server or web browser lost connection to the server. And in those cases,
It's hard to hear you, I'm sorry.
sorry. So sometimes an infrastructure operation command takes an hour or many times. So in that case, there is error between the connection to browser or browser stacks or something like that. In that case, an wrapper kernel take care of the continuation. So we can assure the operations through these kernels. So that is on GitHub, and image on a Docker Hub, so please verify by yourself. So what do we have learned from our experience is, yeah, I'm not efficient for English, so I use a code. So what we'd like to seek is complementary principles, not Ultron, just like Iron Man. That means that in a usual DevOps approach, it goes to the automations. That results in leftover principles. Easy things is automated. Something difficult or cannot be described things remains to human. But through the notebook, these automated operations is still under the control from the human. So what we are going to seek is complementary principles. So because of the narrative feature, the automated procedure is exposed, and we, human can verify what is happening. So those procedures can be human by itself or automated by machines. So it's exchangeable. That means continue to evolutions. There is another phrase which meet my feelings. So we like to, we don't like to discourage development skillfulness. So we like to continue development skillfulness. Also, a tool as a part of ourselves. That's the kind of these things. So automation and automated operation, human involved is quite different. So because of that, we can elaborate notebooks to these structures. Also, we can organize control flows. These notebooks structure is, we cannot create this structure at the beginning. After the elaboration and automation and human elaborations and rethinking, meeting to new requirements, after that, those processes, we can create these things. That's very important, and narrative story can makes this possible. And last thing I'd like to show you is an NB lineage. So in that sense, we'd like to understand how notebooks will be evolved and shared. So notebooks is something different from the programs. So there is a cells, but then in our cases, we reuse notebooks, and then some operator adds some cells or some changes, sometimes changing orders. Such kind of things are difficult to trace and how to, but then in order to evolve notebooks efficiently, we'd like to understand such kind of procedures. So we have a hypothesis, there is a seed notebook, and it will be reused in different many situations. After that, we can refactor and then get more functional and reusable notebooks. So for that purpose, we put function we call the NB lineage. So this extension assigns a unique ID to each cells, and each cell has a unique ID and links to the previous and next cells. Also, when notebook is changed, these histories is stored. And on top of the notebook metadata, there is a list of cells it includes. So in this way, we can trace the changes in a notebook. Also, this unique ID is useful to compare notebooks. even though there is some insertion or order changes, you can verify what has been changed using this information. And as I showed wrapper kernel, we put a link to the log file to this ID. So you can search related operations easily. And one thing I'd like to show you is that this is a kind of development of notebooks. And this line thickness shows the degrees of common means. We call those ID as mean. That will be idea will be inherited. So there are some clusters, and these clusters correspond. We can find these clusters will be, correspond to some specific work. So in this case, we'd like to reuse some old notebooks, but it was 1 year ago. OS has been changed, so we do some changes. And middleware has developed different paths, and we import things from there. And the deployment, this path is just deploy one cluster. But this is a kind of project, so we need to multiple clusters, so explore other way how to multiplicate also. And the result, this is a last notebook. So this type of communication is possible using these tools. This is what actually happening in engineers. So we can revisit how you reuse and how you elaborate things. This is something additional aspect for narrative things beyond the current Jupyter Notebook capability, I think. Okay. So in that sense, we'd like to share experience for all procedural things. But we like to share knowledge, tracing how your idea is developed and elaborated. So through the notebook operations, we think that will be possible. These are still an ongoing practice, and then all tools are published on GitHub. So please give us some feedback. Thank you.
Got about 3 minutes for Q&A. First, that was amazing. Each one of those sections, I think, could have been taught on its own. I thought that was really well done. And a lot of that stuff, like, I want to go back home and play with. So I don't know if I missed it, but I know in a lot of it, I think it's a very interesting use of the notebook. How do you do with, like, dependencies in multiple notebooks? Is there some kind of, like, versioning system? Like, do your playbooks have versions of the notebooks that they're going to run when you deploy them?
Are you questioning about the versioning for notebooks? Because it is difficult for existing tools. When you put a notebook into the GitHub, its different mechanism doesn't fit to the notebook. So we are developing some repository to trace such kind of things. So NB Lineage is a first step for that purpose. So we some people develop the NB Explode when store the notebooks, chunks every cells into the different files and put the GitHub. That's one way. But in that case, whole structure or dependencies between the cells is difficult to trace. So at the beginning, we do implement this mean mechanism. And after using these mechanisms, we are seeking how be the better way. So if you have an idea, please. We'd like to discuss. And yeah, that's the issue.
Do you have one notebook executing another notebook is part of a step? You have one playbook, and in that there's a step that executes another notebook?
It depends. Do you mean chaining notebooks in a way?
Or calling out to a notebook?
At this moment, we avoid such kind of things because it makes some side effect for traceability. Actually, we use an Ansible. So we have something elaborated and immutable. We think those operations are immutable. We made playbooks. And we call them Ansible playbooks from the notebook. So we don't, yeah, we are very open. So we combine useful things within the notebooks. So, actually, there is a way to execute whole notebook as a batch. So we do use such kind of things, especially for report generations. When we develop a report, we create a report notebook interactively. After fix those things, we execute those stuffs from the Jenkins or Coulons or something like that.